analyze the computation. Dora, please.
So I just want to give everyone a quick reminder that we have 7 minutes to present. I'm going to have a little time here to show you. And then afterwards, we're going to spend 5 minutes doing a Q&A from your guys.
All right, great. So we are the Diabetes Squared Dynamos, and we've been working on the AI detection of diabetes distress during conversations. And we're joined by a great team of Mohammed, Sankal, myself, Musa, and Ishant. And we also have two great mentors of Xiaohui and Michelle that have been guiding us through this project. And I'll go over the table of contents quickly. We're going to cover. We're going to go over the background and kind of what the goals are of this project. And then we're going to go into some the data and our technical approach. We're also going to do a quick demo of what we actually built, the clinical relevance and impact, and finish it off with future work and what's ahead of us. And I'll hand it off to Musa.
So I want you to picture a routine doctor's appointment where a patient with type 2 diabetes is asked, how are you doing? Or how are you feeling? They give an answer that we all give, which may not be true, and that is, I'm fine. What if the fine is masked by exhaustion? What if the smiles are masked by the fear of death from complication of diabetes, or even the fear of neglect of medication, or the fear of the constant needle pricks? This is what many patients with type 2 diabetes experiences, and that is what we call diabetes distress. Diabetes distress is the emotional burden that comes with living with and the constant demand of managing diabetes. What if there is an app? What if there is an app which can help detect it early so that patient can get enough emotional support and also help to bring up positive health outcomes? What is the current screening gap? Currently, the screening for diabetes distress is retrospective, which depends on the past experiences of the patient and not a real-time event. As such, it makes the diabetes distress fester for a long period of time before it is detected or before it is too late. And so our project goal is clear and actionable: to be able to detect diabetes distress early using voice and text so patients get a timely support and then derive positive health outcomes. Thank you.
So how do we actually do this? Our main approach is actually going through real voice patterns and actually understanding the voice. So when you look at a transcript or like a recording of someone who is talking about their diabetes, who's recently been diagnosed with it, we can actually notice some pretty clear telltales, which was what it was able to give us the indication that using a neural network or a transformer or an LLM was actually going to be something that we can apply here. So we can see high diabetes distress would be high pitches, like quick tonality, and low distress would be more calm speech and more baseline. So our solution is to analyze how they actually speak during that. We're going to apply AI to actually analyze the speech patterns and the transcript, and hopefully we'll be able to enable timely support when distress is found in a patient. So to go over our data sources quickly, we actually are building off a study that Michelle, one of our advisors, led, where they took in a lot of people who have recently been diagnosed with diabetes and kind of talked with them, recorded the session, and was able to give us the starting point of what we're going to work with for our data. So we'll get into quick 2 demo videos. This one.
Just to understand, the people in that little study had already been diagnosed with diabetes?
Yes. Okay. So this is our first tool that we built, and this is going to be the voice analysis. So what you're going to see here is we're going to actually upload a recording, and we're going to have a neural network that we have been able to train actually analyze this analysis. And this is using 3 main different technologies. And the first one is MSCCS. It's a little technical, but essentially what you can think of this as is like the fingerprint or the texture of someone's voice. So you can think everyone talks in a unique way, and that's what we're able to detect and discover here. We're also looking at the pitch, and this is obvious. You know, if someone starts screaming in the middle of the conversation, there's probably high distress, or if there's like a quick increase in voice or an increase in effort or something like that. And it also goes in with RMS energy, which is how much energy someone's putting into actually speaking about, and speaking of their experience with diabetes. And what we can see here is it actually graphs it out, and we're able to see the higher numbers are actually indicating us higher diabetes distress, and the lower numbers, or the more baseline ones where you see most of the conversation, indicate that it's more of a baseline conversation. So in this specific example, there was quite a bit of fluctuation where it started off really high, very distressed. It could have been also stressed just due to the actual conversation and the topic. And around the end, the person started kind of easing out and showed more signs of being relaxed. The second tool here is the AI distress analysis tool. So this is actually going to take the transcript and focus more on the literal wording that the AI is using. So here we're able to upload the transcript, and then we're going to use two different main technologies. We're using heuristics, which were actually based on other linguistic tools that have been proven and studied. So we can kind of ground everything in some truth here as well. And we're also leveraging a frontier LLM that we've been able to fine tune specifically for this use case, where we're able to now use the heuristics to ground the LLM's understanding and analysis of this. So here we can see it's giving us a score, which is from 1 to 100 of how distressed it thinks this patient is. We're able to get evidence from the transcript, and if we click through this demo a little bit, we can see at the very end, we actually get some supportive recommendations from the AI as well. And these aren't diagnostic, these are just supportive, quick little things. Go back to the slides. Cool, and then I'll hand it off to Sankalp quickly for a little bit more about our technical approach.
Okay, thank you for that, class. So let's talk about our approach here. So what we did, since we didn't have any target label, so we divided the data points into clusters. If you see on the right side, you can see there are 5 clusters. And what are these data points? So every data point is just an frame from an audio, which has some acoustic features. So we used a clustering algorithm here, that is k-means, and we divided all these data points into clusters. Now we have to keep in mind that these are just random clusters. They are not stress level. So to convert them into stress levels, what we did, we saw that some features are positively correlated with stress, and some are negatively correlated with stress. So what we did, we took the negative correlated features and then converted their cluster means to positive by multiplying it by, let's say, -1, and computing a weighted mean. We found the distress levels of starting from 0 and going to 4. 4 means at its high. So here, if you see, this is the real-time distress trajectory of 3 participants. If you see for the first participant, the distress level is more stable, ranging from 1 to 2. If you see the second and third participants, it has a more variable range, that is ranging from 0 to 2 and 0 to 3 in the third case.
I'll quickly wrap it up, so I know we're going over a little bit. But for our clinical relevance and impact, I mean, it's pretty clear having nurses and people expected to find these super subtle tone changes and everything isn't realistic, and it is a real problem that we do want to solve. Here's some quick future work. We do want to expand our data set so we can actually improve our model to be a little bit more accurate, and because it can always be better, it can always be bigger. And we also want to be able to implement a classification, so we're able to actually take both the heuristic and LLM analysis of the actual transcript and combine that with the voice analysis. Here's some references of studies that we have built off of, and thank you so much for listening to our project.
Yes, 5 minutes from judges, ask questions, stay on stage. You may want to stand over there, so clear communication. Okay.
So I wanted to ask, so if you think about the use case, we're thinking that the end user, like the audience of the recording, is the medical professional?
The patients are the users will be of this, and the medical professionals will be using the tool. Oh yeah, the medical professionals would be the users who would be analyzing the patients, using the tool to understand distress early. And so that way they can use proper measures to, provide, enough care so that they get out of this, and
Okay.
it will be helpful.
And then, where does the recording come from?
The recording is coming from the conversation that the specialist or like the caretaker is able to have with the patient, and we just take that recording and we can implement it into our tool.
Okay, so there would be an additional step where the person would consent to being recorded during her visit?
Of course.
So this is an app that the user would be able to download and use it off their
Ideally it could be both. It could be the user themselves if they have a recording of themselves talking and want to understand it better. But also, I think our main target audience and the main consumers we want to have is going to be the actual hospitals and the actual clinicians that are dealing with these patients.
You may want to stand a teeny bit back so that you don't have your back to
Sorry.
the other judges. Thank you, though.
Yeah, I actually have a question from Paul English. He just texted it to me asking, could this voice detection methods be used by other medical conditions such as depression and anxiety?
Yeah, that's a great question. And yeah, it 100% can be. This specific model and this specific use case, we did specialize it a lot on diabetes, specific things that people will talk about. But in the big picture, in the greater, like, looking in the future, it'd be great to be able to apply this to all sorts of different conditions, yeah.
Oh, and may I ask a question from myself? Just like from personal experience, because we did some research on direct-to-consumer apps in that category, people usually don't love to be told when they're anxious. So if you can find a way to make it a little bit more fun, like I don't know, maybe get person to say some affirmation or something, right? Because it's already like quite a stressful experience, and then the app is telling you, oh, we're seeing, you know, the stress markers. So like making it a little bit more fun and engaging in order for patient to actually, you know, be, because otherwise they'll just like put it down and like, okay, I already know I'm stressed. But
I totally agree with that.
That's really an important and really a good suggestion from your side. Thank you for that. We can work around that.
Yeah, I just want to build on that actually. I think you could think about not only expanding sort of the app's efficacy in terms of different types of stress, which is going to lead to a question in a moment, but also there may be a slightly different tool that an individual is going to use, and then how the app sort of plays back information to them versus how a healthcare professional might use it, so that you can distinguish the use of the audience. So one question I have is, it sounds like that if you just do the voice analysis, you're able to detect levels of stress, although one question I have there is, do you need some sort of baseline for the person, right, in order to be able to know that, you know, whether that's out of their normal range? So that's one question. Could lead to then some limitations on what particular ways it could be used. And then my question is, just to make sure I'm understanding this correctly, given that, then it really does become the qualitative analysis of the language that participants are using in order to isolate, you know, what you believe is the diabetic distress that's manifesting itself as stress.
Yeah, and I'll answer both of those questions kind of together. So for the first part, you're 100% right. Having a smaller data set like we have to deal with does make having a ground truth like a bit of a problem, because we're not able to have a totally comprehensive data suite where we can see how every single different type of vernacular is being analyzed. And that is something we do want to work on in the future, get more data, be able to apply this across the board and just be more accurate, as accurate as we can be. And regarding the second question, that was about like kind of why we're doing both of these. Having something just about the audio, it's a really, really solid start. It's able to kind of give us most of what we want. But also having the second layer where we're able to apply proven linguistic tools to really get into the nitty-gritty of the actual words being chosen. It's able to kind of combine those and get us a more accurate score altogether.
Yeah, thanks for your response. And I guess I was trying to say, actually, I think you absolutely have got to have the linguistic analysis in order to be able to isolate the type of stress.
Yeah.
So I think that's really important, actually. One thing that I would also say, just as a suggestion, and I know we really compressed your time, but given the prevalence of diabetes, and that actually we know there are plenty of studies, and I'm not an expert on this, but I know enough that it is a growing problem, not just here in the U.S., but globally. You know, so to be able to make the case for why this is an important app, I think that'll help you too if you can link it to trends, right?
Yeah.
That increasingly more people will be able to benefit from this and find it useful.
Thank you.
One last question. Could you use one sentence to summarize the collaboration between computer science and nursing?
One sentence.
One sentence.
I guess what it would be, what I would say is we're able to take real medical and emotional problems and solve them using state-of-the-art solutions.
I do have questions for you, but I think in the interest of time, I'll ask them for you on the thing. But I would like you to think about the actual science. How effective is it? Can it be used for early detection of diabetes? If these people were already have diabetes, what is the added clinical value of knowing that they're in distress? And I mean, what are the implications? Do we have to do something about it? Do they do something about it? Is there a financial cost? So it would be good to understand that and see what it is. And the last thing I'd like you to look at is the percentage if you are indeed predicting, because there are plenty of products out there that are doing well. You look at Cologuard, which only predicts it 45% of the time, but it's still a commercially viable product. So I'm not sure what your percentage detection will be, but if you can give early detection, then there's a real possibility.
And also, sorry to do this up, sorry, wait. Right now you're focused on diabetes, which is really specific and really interesting. The voice recognition element of this could make this really relevant for other settings that are completely non-clinical. Two things that come to mind are Zoom meetings. So having that ability within a Zoom platform where the person leading the meeting can tell if somebody's getting upset or getting stressed or something like that and get ahead of it. Similar with education in that same way.
Oh, that's such a good idea that you can actually hear if your opponent, right? Like,
yeah, you can get ahead of the conflict a little bit, you know?
I like this. Like there's so much use to the technology. Man, it's awesome. Awesome.
Well, thank you. Nice
Great.
job.
Thank you guys so much.
So really quickly, I would just like to briefly mention our People's Choice voting. So you don't have to do it right this second, but after every single group has presented, you should see flyers going around the room with a QR code on it. You can follow this QR code to initiate People's Choice voting after all the presentations are said and done. There will be a special award given to the team chosen specifically for People's Choice, and then there will be a top 3 choosing from the judges specifically. But thank you. Remember to do the People's Choice.
So the next team is Team Berger, and the product is segmented digital subtraction and geography images.
So for judges, this is the last table row, okay? Last table row. Because we decide, they draw their number for the continuous sequence this morning. So that is why we printed those reading sheet. I don't know the exact. Okay. Go ahead.
Hi everyone. Today I'm going to talk about segmenting digital subtraction in geography images. My name is Masa, and my teammate is Srikar, and he's away for a conference and couldn't make it today. And our faculty member is Professor Funda Durupinar. So, how can I go? Next slide. DSA image or digital subtraction in geography is a widely used imaging technique for tracking the blood flow in brain or other parts of the body. And the clinicians use this imaging technique a lot for planning for the surgeries and during the surgeries for tracking the blood flow and measuring the blood flows and, for example, for detecting if the patient has stroke or other diseases. So the DSA is created by subtracting background tissues, like for example bones, from X-ray images. Can you go to the next slide? So segmenting the DSA images is very useful. By segmenting images, we mean outlying vessels in the image. As you can see in this slide, on the bottom you can see the DSA image, and the top one is the, thank you, is the corresponding segmentation. And the segmentation helps doctor measure, plan, and track the blood flow. And without having the automatic segmentations, they need to do it manually, which is very time consuming, and it's really hard to do. Topology is a very important thing in DSA images. Topology means how vessels are connected and how they are branching in the image. And doctors can select specific part of the vessel and see where it goes, and they can see, they can use this technique during the procedures to see, for example, where they need to inject chemicals in the vessel. And it's very important for planning and finding the vessels during the procedures. The state-of-the-art methods for automatic DSA segmentations have some drawbacks. For example, they can't detect the small vessels. By small vessels, we mean vessels that are less than 2 pixels wide. And they are usually disconnected, as you can see in these images, because they are using one-shot technique, and the state-of-the-art segmentation methods will predict everything all at once. But our solution for segmenting DSA images is a sequential way. So we want to follow the vessels step by step and do the segmentation sequentially. And then in this way, we can build a vessel tree, and we can preserve the connectivity, which is very important, and even more important than having accurate segmentations in DSA segmentation. So for following the vessels step by step and solving this problem sequentially, we use reinforcement learning, or RL, which is a computer science technique that we train agents and models by trial and error, and by giving feedback and penalty to the agents. And over time, it learns the best strategy for solving the problem, which is called the policy. So for our problem, we have 3 sections. We need to first track their curves. In this image, the curves mean, by curve we mean the vessels, and then we need to detect the bifurcations in the images, like which are the branches in the image. And then at the end, we need to construct a tree for segmenting the whole image. To simplify the problem with reinforcement learning, we started with solving a 7x7 maze, which will learn how to solve a maze step by step and sequentially. And we trained a model that can take actions and eventually solve this 7x7 maze. And we use Q-learning to teach the agent to this policy. Can you play it's a video. Sorry, can you play? So we successfully trained this agent to solve the maze. And then we scaled up the problem by having a 20x20 maze. And to solve this problem, we had deeper CNNs. Could you, yes. And sequentially, it can solve this maze, and it can find the optimal policy. And then we adapt the same strategy to train the segmentation model. And we started from training a binary curve tracker to follow the vessel like this path. And then we gradually added noise, and we used curriculum learning to improve the robustness and have a generalized model. And at the end, could you, sorry, thank you. And at the end, we have this result where the agent can follow the direction. And we have a library called Vessel that can snap all these tracked paths to the center line of the vessel. And it can also find the corresponding vessel width, and it can solve the problem sequentially. So in the next step, we need to generalize it more by curriculum learning, and we also need to add bifurcation detection so that it can learn how to decide in the branches. And then at the end, by using these two steps, we can construct the whole tree of the DSA image. And that's it. Thank you.
Hey, please. Super interesting presentation. I knew nothing about this field. Maybe like what you were talking about is like not super novel, but to me it felt genius. I'm like, wow, I didn't know people use CNN. Like what you presented seems genius. But since this is a startup competition, I would love to hear more of your thoughts about like how do you have any idea how to like commercialize it or like how it would get it.
Yes, so it can be used. So we already have collaboration with Brigham and Women's Hospital, and we already talked to a lot of doctors, and radiologists and neurosurgeons need this segmentations for their procedures, and it could be added to like neuronavigation systems and some other applications during the procedures for radiologists and neurosurgeons.
Are you far enough along, or do you have enough data yet to be able to answer questions like how much the accuracy actually, like what percentage improvement is there in accuracy, and how much faster, right? Because one of your pitches here, right, is that it's going to increase the speed of diagnosis and the accuracy. So do you have some data yet on what, for example, a medical professional could expect in terms of improved efficacy and efficiency?
Like numerically?
Yeah.
So one of the things about reinforcement learning is that it doesn't require data. Or it requires less data. And since we are using curriculum learning, we are using synthesized data right now, and we haven't tried it with real DSA images yet. But the way that we analyze the results or the accuracy is how many bifurcation it can detect, and like how similar the tree construction is to the like real DSA image, like the percentage of bifurcation detection with the corresponding segmentation.
Is there any sense of how much time would be saved? Because clearly speed and accuracy are the key here. And if surgeons can do more surgeries, then that's a major benefit by itself. And if individual surgeries themselves go better, those are both good. So what is the metric itself? How much time does get saved? How much time? And what will the role of the surgeon be? Will they still review the DSA quickly and validate it? How do you see it working?
So in terms of time, it doesn't save like time that much. The good thing about this approach is that it doesn't require any data. So usually when we want to do automatic segmentation, we require a lot of data. And for those manual segmentations, which are our like training data, we need a lot of clinicians to do the segmentations. And they disagree a lot. So if you ask two clinicians to do the same segmentation, they are really different. So, and it takes a lot of time for them to do the manual segmentation, but with this approach, we don't really need those segmentations because it learns it by trial and error. So the time saving is for like generating the data set. It's not faster during the procedure and in the prediction.
Yeah, no, I meant faster planning for the procedure, so which can sometimes be significant.
Yeah.
So that is potentially a major benefit. Is there going to be any IP created? I mean, is your approach unique enough that it can be protected if you indeed succeed in making these fast DSA?
So can you?
Is there any intellectual property that, I mean, if there be barriers to entry, once you have your approach, can it be protected or can others copy that approach?
Like if I open source everything, they can copy it for sure. So we already have some papers for these segmentation with reinforcement learning, but for CT images. But for this specific approach, we need to do, right now I'm doing a lot of trial and error because we have to balance the reward function. Reinforcement learning needs a reward function, and the reward and penalty should be balanced. So I need to do a lot of experiments to balance those two, like penalty and rewards. So yeah, like balancing it requires a lot of experiments, and it can't be they can't reproduce it without experiments.
Could the next team come up, which is Team PM, and their project focuses on personal AI memory for people with mild cognitive impairment?
So Team PAM judges is the table row, the fourth table row, PAM, Team PAM.
Good morning. We Team PAM. I'm sorry. Okay. Good morning. We and Team PAM are pleased to introduce you to Pam, and Pam will introduce all of us. Advance the slide, please. Thank you. And thank you. Oh, thank you.
I'm so excited to be here with you today. Let's start by meeting the amazing PAM team. Qingling Gao, PAM CEO from gerontology. She is a smart elder care expert with more than 10 years of experience. Catherine Richmond, PAM COO from nursing. She practiced psychiatric nursing for 15 years and holds a PhD in theology from Boston College. Chen Jiezheng, PAM CTO from computer science.
Yes. Go ahead, please. Thank you. Okay. Go ahead. First one. Okay, so Pam is a personal integrated memory assistant, voice-based companion, and she's designed to support memory, mood, and daily activities. And she's a human-centered digital companion. And she transforms daily conversation into meaningful interaction. So she is an older adult AI companion. So how does she work? The technology architecture, voice interaction, cognitive analysis engine, emotional AI module, personal memory vault, and then the user experience flow, the user speaks to Pam. Pam can speak back to the user. And she records, she summarizes, and she structures the content. So, in other words, the older adult using Pam can tell their story for themselves to remember things that they want to remember, events in their lives, or, for example, where are their keys? Do they have their keys? Pam, can you find me my keys? Right? Or, for the children, do you remember the trip that we took, 20 years ago? And then they can pinpoint the place where it occurred, on GPS, or the families can. Because oftentimes, obviously, older adults, they tend to have trouble with technology. So oftentimes it's going to be the families who will use Pam. And originally, or initially, I should say, we plan to pilot Pam with older adults with mild cognitive impairment, but that's just for a pilot. Anyway, let's go on. We are running out of time. So what is unique about Pam? Well, there are many memory aids out there, and so the memory aids tend to be either AI, like ChatGPT, we're really familiar with these days, and ChatGPT is emotional AI. That it responds to emotion, but it's not cognitive. It doesn't support cognition. And then there are apps for older adults specifically that support cognition. And those apps they're not emotional AI. And so Pam does both. Pam is kind of one size fits all, supports cognition, it's also a companion. And so the emotion recognition engine is built on effective computing, frameworks validated in gerontology research. So Pam is going to be evidence-based. And we're very concerned about privacy and ethics. So Pam will be it will not save to the cloud. It will, with appropriate consent, record voice, but it won't save the user's voice to the cloud. It will be locally based. The user, their families, their caregivers, they will have control of the data and being able to delete it. So our business model.
So actually, for the business model, we want all the older adults and their family members can use that one. So the whole picture is we want everyone like B2C, and we promote to the consumer. But first one, we will start as a pilot, and later on we will have to the cooperation with some companies, and we start with B2B2C, and later on we will start like the consumer line. And also we want everybody affordable, and everybody can use it, and their family members, and also the institutional caregivers.
So we'll have a free version and a paid version for individual and family users. We'll also we're hoping to partner with institutions, insurers. So kind of we want to reach everybody with Pam eventually, but we're going to start small. So again, I know we're running out of time, so I won't really go through this, but just again to show you that the apps that are out there don't do everything that Pam does. Each of them does something, but they don't do everything. And again, our potential collaborators, we have a pilot phase, validation phase, scale-up phase. I will spare you the details, but we have thought of that. We do have that, and we're happy to give you the details. Okay, so vision and impact. Aging with cognitive decline should not mean losing one's story, one's identity, one's connection. And Pam can not only record the stories, but arrange the stories, into a coherent whole. So it's emotionally intelligent AI. And we can transform, through emotionally intelligent AI, PAM can transform daily care into moments of meaning. So societal impact, it supports healthy aging and well-being, promotes emotional resilience, memory preservation, and bridges healthcare and home life through compassionate technology. So PAM, to close, PAM preserves not only memory, but the relationships that define it. Thank you.
Sorry, go ahead, Bernie.
I was just gonna say, first of all, you really identified a problem, a big need. There's a lot of lonely people that are aging, and the numbers are really high, so hats off to you for that. I think that the potential is really, really robust here. I think that you could integrate with a lot of other senior supporting tools, communities, individuals. That's really exciting. A couple of things to think about. I think that you guys have to be thinking about security of the app because seniors are getting scammed a lot. So if they're recording proprietary, personal details, you want to make sure that you're guarding against hackers. I also am curious if you are thinking about, you might have said this a little bit, so please elaborate if you don't mind. If you're thinking about integrating family and friend activities into the app.
We're really thinking at this point, I won't say most, but many older adults, I found in my own research, really they don't use tech. Their families use, they have proxy use.
Yeah.
And so that's really what we're envisioning, that either, the older adult will use the app themselves, or as many do, rely on family, or caregivers. So, but if they themselves, possibly with the help of their family, if they need and want that, are in control of their data. And yes, absolutely, privacy, is an absolute concern.
So I think I had one of the sort of same concerns was that, the target audience, if you're looking at this, is the aging population, and their adoption of technology, especially at that level. I don't know if there's some onboarding or there's some way that you could sort of encourage them or bring them, or I don't know if the UI is sort of set up in a certain way that makes it a little bit more intuitive for them to use the application.
We are thinking like two parts. One side is about older adults. They can like record their life story. Because when we work in the longitudinal institutional for a long time, and when the older adults move into our community and in nursing homes, we do have the file to follow their milestone, their wonderful time and their whole life stories. But they're all recorded by paper. But we want to transfer all the things by AI, we can know older adults well. And also, another section is we apply to their family members, also their healthcare caregivers. Because the caregivers, they change a lot in the institutional. So we want no matter how many the caregivers they change it, but they focus on the person, they focus on the older adults, so they know them well, their habits, their family, and their loved ones, their the moments they really care about that way. So that is the vision and we want to. So we do well think here about the UI and UX design because we need them use that one easily, to just randomly just record something and just again remember everything and have the emotional interaction together.
Thank you.
Yeah. Great presentation. I guess you guys are still working on UI UX and how it works, but maybe you have some ideas through this one phrase. I guess converting daily conversations into meaningful interactions. It didn't sit well with me because I wish senior citizens just had like, you know, more meaningful interactions rather than just like with apps. But like, how does it work? Does it constantly listen, or like does patient have to talk to it and then it like memorizes? How do you know?
The older adult would need to talk to it. It's not like Alexa, you know, listening all the time.
So when we create this app with that trigger, we can try to call this assistant out and through the phone, and also we save the whole data is in a local phone. It's kind of a second memory, second brain in your phone. It can help you to recording all the things and trying to recording all the trigger things, right? So for example, you're trying to make this map, go to somewhere and go to some dictionary, but they just make it in a calendar, right? But you have to make the calendar reminder for yourself. But our app will automatically search this information through the phone applications and to tell you, you have to going to do in a certain day, you have to going to do where in a specific time. For example, they have 10 minutes earlier to remind you, you have to take a bite to UMass Boston, and you have to go into the meeting, join the Zoom, right? So you just reminding yourself through the app. Also, you can try to get the voice to stay with you.
And especially if it can remind like your kids like to take you to doctor appointments, because a lot of like children actually say like, oh, I need to track all of the schedules for my mom, so it can like arrange that, you know.
It's kind of the phase 1 for everybody. Also, we have the phase 2 for the patient, for the Alzheimer. You can see we have the treatment called the memory treatment. So it's kind of make the Alzheimer patient will be easier to forget something. But when we to loading, because the phone have the location organization, right? So we have to go to a specific place. It will be help you to memory what doing in here, right? So for example, I come to the UMass Boston. You remember we study a graduate and a master PhD program in here, and we meet with a Provost and with a Kate and the professor studying here, right? To help us bring all the memory together.
I'm also just thinking, given this discussion, right, is there potential here for not only helping the individual, like, remember, but could it then give tailored prompts to caregivers and family members, essentially the advice, right, about how to improve even interaction, not just memory or technical functions, but improve interaction with the person that will be helpful to, you know, to them, right, in terms of how they receive information.
Be nice to your mom, right? So daily reminder, be nice to your mom.
Yeah.
That's a great idea.
Yeah.
Definitely. So we think about phase 3 as we're still in the development.
We're thinking like one is like we know the OLED as well, and then we will like share their stories like your like family members, and also we'll give them some functional like games maybe, because we focus on the typically the group people, their cognition is declined, but they're not going to like some disease. But we just want to maintain their their memory and just that is.
So, you know, we're envisioning piloting the app with older adults who are competent, you know, who are not diagnosed with dementia.
Paul has a comment. He said that he's met with your team once before, and the feedback was that you guys should partner with Limitless AI and or Ray-Ban Meta V2 sunglasses.
Yeah. Okay. Thank you.
Thank you.
The next team is Team Elliot Koo, and the project is Pioneer, which helps teachers in early childhood education on how to make lessons/decisions that are equitable and inclusive.
Second table row. Okay.
Can everyone hear me without the microphone, or do I need it?
People on
It's
Zoom.
all right. Can you hear me?
Yeah.
Oh, on Zoom though.
It might be on Zoom.
Okay, right. I was gonna say I can juggle. I'm a kindergarten teacher, in case you couldn't tell. It's also Halloween. I can't show up in my elementary school without some kind of flair, but. Oh, so I need this, right? Great. So I'm here today to share Kind Mirror, a reflective assistant for ethical early learning practice. This project is a collaboration between myself, Vanessa Elliott, and Dr. Dahi Koo, who's my faculty advisor, and she works for the early childhood department. I've been a Boston Public Schools teacher for 25 years. Most of those years have been in kindergarten. I know it's redundant. And I can tell you that teachers are clamoring to include AI in our classrooms, and there's a difficulty there because the students are excited to use anything, but we need some guidance and some outlines on how to include AI in our classrooms. Can you press next slide? Did that work? Sorry. Thank you. Thank you. So imagine you're planning a circle time for tomorrow. You're not all teachers, but you once sat at a morning meeting on a rug with little friends and your teacher. So when we're sharing stories, sometimes we're wondering, how can I make this more inclusive for our dual language learners? Or you might be reading a storybook and wondering, what implicit messages might this send to different cultures and the races represented here in my classroom? So early childhood educators are increasingly expected to use technology in the classrooms, but we often lack guidance on how to include that in an ethical and equitable way. Professional reflection is also essential for teacher growth, yet having a human coach is not always possible or affordable. So Kind Mirror is also a way to have mentorship, not replacing human interaction, but maybe as a Band-Aid in between coaching and collaboration with your teammates in administration. Next slide. Thank you. So what is Kind Mirror really? It's a large language model power assistant that helps educators reflect on their lesson plans, classroom management, and interactions. So instead of giving direct answers, it asks open-ended questions like, how can I make this activity more inclusive? Some of our students have limited mobility. Some of our kids have trouble producing speech and sounds and work really hard in a small group, but we want to help them be successful in the large group too. We also might ask, what implicit messages does this storybook send? There's a lot of different texts that we're required to use, and sometimes when you bring in a fun Halloween read aloud, you need to check the background and make sure there's nothing accidentally offensive to some of your students. So it's built on ethical AI frameworks and early childhood pedagogy, and it prioritizes privacy, educator agency, and professional growth. So in short, it's a mirror, not a manager. Good, the next slide. Thank you. So it's built on 5 key pillars. Oh wait, there's 4. Combined 2, hold on. But there's ethics and innovation. So there's bias mitigation there, transparency and privacy from the ground up. We're not entering student data. I could put in some concerns for a student that has a different way they learn best without putting in their name, date of birth, or their SASID number or anything like that. The teachers are co-designers, ensuring that the tool is relevant and usable, and it fosters collaboration among students, faculty, and policymakers. We're hoping ideas from this project can evolve into funded research or curriculum models or institutional tools. And it's not just a tool, it's meant to be a launch pad for ethical AI use with our youngest learners. Next slide. There's only 5 slides. That's true, there were 6 slides. I was asked to get rid of one at like 12:01 a.m. this morning. I did that. So let me just wrap it up, Sig. It's, we use a vetted large language model based on NACE, the National Association for the Education of Young Children. So we're using some frameworks that exist to inform how our questions are answered. And I think that's it. Thank you. I'm happy to take questions.
So, I guess the recommendation that the large language model makes is really based upon the information it has. So over years, I'm assuming I don't know how you go about collecting and adding all that information in there so that, I don't know, it's longevity studies or something so that it can make a good recommendation.
That's a great question. I know we have the documents that will follow closely, but how to get those there, those are next steps.
First of all, thank you for being a kindergarten teacher. Most of us couldn't do it. I'm wondering, I know that you said that you don't collect any data. At the same time, have you thought about, or is there a process right now where you're loading demographic data about the class that you're teaching so that the AI can focus on cultural elements that are relevant to the group?
That would be a next step. This is still very much conceptual, and we're building a team to get to some of the practical steps, but that is something we'll have to be able to inform programming without revealing anything personal or private about a student. But there are a lot of best practices that we use in the classroom for instruction that works for kids based on their needs, like their strengths and weaknesses. So we can use some of that without revealing anything personal about the kids.
Yeah, because my thinking was that there's so many specific cultural elements that can apply, and you're in a very diverse area. So, yeah, just it's a really well thought out and an important way to bring AI in at the youngest grade. I think it's really exciting. So yeah, nice job.
Thank you. Any other questions?
Yeah, one quick question. And thank you for your.
You don't have to have a question.
But I do. Well, no, I was just thinking that as you develop this and build it, and because there are individual, right? And you know that some of these and so, an individual can just use it like as the mirror for self-reflection, but you can also create some communities of practice, like where folks are using it. And you didn't even mention there could be institutional uses. So, but have you thought about if you have those different layers, who some of the partners might be, with both in terms of how to get the word out, but also then how to use it at the various levels.
Yes, we're thinking about that. Is this something at a federal level, a district level? Is this, we also discussed, is this something we want it to be accessible to all? Is there a paid version? Is there a free version? So these are some of the things we're ironing out. But thank you.
Thank you.
The next team is Team Guan, and the project is a tool-assisted VLM for long video question answer.
Hello everyone, my name is Hao Wenguan. I'm a second year PhD student at Computer Science Department. I'll be introducing my project to a system vision language model for long video question answering using LLM. This project is guided by Dr. Si Chaopei, who is an assistant professor in computer science department. Let's dive in. All right, here I give a quick example about what this project is working on. Assuming we have a long video, and we want to answer a question that where did I put the white cup? In this long video, you can see that it contains of a lot of sparse events. In traditional vision language approach, when it tries to answer a question like this, it will read the video with a fixed rate frame tokenization. However, the problem is that when we are working with long video, it can be very, very large. It can be a 2-hour long video. It can be multi-gigabytes of data. So it's very difficult to feed entire video into the vision language model, and it's not applicable. So, and also, when we are working with long video, inevitably, we want to sample the frame very sparsely. So it can be also the case that we miss the key moment to answer the question, because usually the answer to the question can be within a very short time frame. So with this motivation, we need a system that can ask for more frame when needed, where a need happens to answer the time-bounded question. So the goal here is that specifically we define it as given a natural language question about the video. We want to output the exact time step to that time window. Why this matters and what this can do. With the video question answering, it can help us with certain events such as sports highlight, civilian review, lecture search, and accessibility, such as quickly finding the part that matters without heavily using human labeling. Why I work on this project is that I used to work on a lot of long context vision language model training, and this project connect my research to real world user and real use case who needs fast temporal search. Here I give few comprehensive real world scenario that we might see when working with video question answering. First, let's see the safety. Like we can ask where does the person fail or fall, or when does the car run through the red lights. In terms of sport, we can ask when does the goal happen. In terms of education, we can ask when does the professor derive the loss function, or media finding the scene where two dogs appear on one behind another. And the common question that we are targeting on is that specifically the short event happens in a long video. So that's the background. The approach that we derive for this task is we deployed a vision language model, open source vision language model, Q1 2.5 VL 7B version, and then we equipped it with a tool to use it to sample frames. Specifically, let's see what exactly the tool is. As I said, the model is the open source Q1 2.5 model, and the tool is that we allow the model to get additional frame from a certain time window. For example, it can be like from 1 second to 5 seconds, and then the tool will return us the evenly sampled A frame from that time window. An analogy I would like to give on this example is usually for vision language model, existing vision language model, it has only eyes and mouth. It can only see and speak. But with the tool, I equipped it with VLM. I'm like equipping it with an additional hand, allowing it to manipulate with the word, interacting with the word to be more smarter in that sense. I have a layout of a quick workflow about this approach. I will have a more detailed example in the following, so I'll skip that part. And lastly, we have to design some certain rule that to have the VLM working in certain ways, such that we can only allow it to make one tool call at a time, and it has to once it finds the correct time frame to the question, you have to return the answer in certain template. Let's see. Here is our reinforcement learning setup. Like we said, we allow it to interact with the tool in terms of multi-turn and then with tool use. The algorithm we use a little bit more technical stuff is we use the reinforcement learning with GRPO algorithm, and the state for training the model is the dialogue history and its past tool use. And the action is like every other large language model that is it predicts the next token repeatedly. Finally, to evaluate how well the model roll out to operate the tool, we have to evaluate its entire performance using the IOU, which stands for intersection over union. Like we showed before, the model are expected to print out the correct window for the events. And also we have a ground truth. So that at the bottom of that side, I lay out a calculation example, how exactly we evaluate the model. If the ground truth is from 10 seconds to 16 seconds, the prediction from the model is 7.5 to 14.5. The expected reward for that output will be something like a 0.53. And that reward value will be used to iteratively refine the model to do better in the next run. Last and most importantly, this project runs on UMass Boston. It's powered by UMass Boston Chimera 22 server. And here I want to say special thanks to school as well as Paul, because this is a $500,000 server, and without it, we cannot make this project real. Here I give the font is quite small, but I give a complete example of what an interaction can look like. At the beginning, at the very top, most of the portion is defining the question and some necessary additional information that needed for the model to understand how to use tool. And following, we have the user's prompt that initialize. We start with a frame, an evenly sampled, very sparse frame given to the model to give it a general sense of what the video looks like. And then we ask a question. For example, here we ask a question: there is a duck behind another duck in the water. Where is it exactly in terms of the time that moment happens? Here we have the AI's response. So as the AI, we wanted to use tools. So here in this example, the AI calls the tool get frame, video frame from a certain range from 0 to 49 seconds, and we will execute the tool on our side and sample a certain amount of additional frame evenly from that time window. And then we return the result back to the model. The model can execute this tool call for many times, and then eventually, once it locates the events, it can return the final answer prediction.
I think you already used your 7 minutes, right?
Okay,
so
sorry.
Laura, you have to be strict on time management. We're behind schedule.
All right, I'll probably just
stop,
that.
stop. Okay, question for judges. We still have 2 more minutes. Okay. So Laura, you have to. Thank you.
It's an interesting idea. How will you know when you have succeeded? What is the end goal? I mean, the end goal is better highlights, to use your sports example, generated faster somehow, and how will we know that it's better than the alternative?
Yeah, the end goal is definitely we can locate the precise location of the moment every time and reduce human labeling, because for a long video, for a human to do it manually, it takes a lot of time and it's very tired of repeated work. It's not very interesting to do it. So with the model, we want to automate everything. So
that's the part I was struggling to understand. Yeah. How will the model know that it needs more frames? Because that seems to be your differentiation, that normal standard frame rate are doing it at some rate. You have a sort of a thinking frame. But how will it know when to apply the thinking frame? Or is it always applying the thinking frame and therefore all its videos are longer?
Yeah, it can judge us like thinking like a human. Like if I don't see the moment that I'm looking for in the existing given frame, I will ask for more and make educational guess. Where could it be? Like if I have not seen the later part of the video, I can ask for more frame from the later part, and then you can search for repeatedly, like narrowing down into the window to eventually locate the frame. But that is a good question, is that it is possible that it never finds, or it takes a long time to find it. But this is something we wanna refine further to make ways to look for ways to make it faster, efficient, and use less computational resources.
Well, I have a perfect partner for you. So somebody who works on TV broadcasts using this. So if they validate it, then it's something good.
Sounds good. Thank you.
So nice job, and I really like that you listed a number of different industries that could potentially benefit from this. I'm gonna echo Shubro because he often says this. It's really important to quantify what exactly the value is. So my suggestion to you would be to identify maybe 3 different uses. Maybe one is security, law enforcement, court. Maybe another one is media use. Maybe one is residential, right? Because a lot of people are using Ring cameras. And then I would just run pilot studies where you have a few people try to do it without your tool and then do it with your tool and actually quantify how much time they're saving. This type of data can really be used in marketing and in figuring out how to segment your product. And it could be quite lucrative if you can show that the time that a user might save going through long footage can be drastically cut. You can have a really big commercial solution.
Thank you so much. That's a good suggestion.
Great presentation, and obviously you know this is like a big problem, especially like in Hollywood, because when like someone films like hours and hours or like I don't know days of footage, and then they have to cut it and I'm sure you're aware of like also like plenty of existing solutions. I'm just curious what actually to add to what you said. I think if human eye you know how you're describing yours would be using more sort of frames per second, right? But sometimes it's something human eye won't even be able to distinguish. So in my I'm thinking maybe it's not that as applicable to Hollywood because if human eye doesn't catch it, then in a movie probably they wouldn't be searching for something which is human eye can't catch. But for security footage, for example, right, when something happens really quickly, someone stole something and value is really high, okay, if we got this thief, security or safety enforcement, I think that there could be a very interesting market which no one is even thinking about because everyone's oh, Hollywood is so big and they have a lot of footage, let's sell it to them. Those are just some thoughts. I don't know if you want to answer.
Thank you for sharing your ideas. Very valuable.
Thank you.
The next team is Team NeoShark, and their project is an AI platform that streamlines the study process and helps students.
NeoShark.
We'll try a really quick experimental thing to see if it works out well. We want to, part of our presentation has to show our screen. My screen, this laptop, hopefully we can get successfully over here.
Everything copied.
Yes, gotcha.
You already used 10 seconds.
All right, well, I will do, would you like to introduce yourself?
My name is Berger, and you can call me Nim Yan if you want.
Yeah, use the mic.
Oh, sorry. Yes, as I say, my name is Olivier Kibler-François. I'm a CS major. And also my background was engineering and I transferred to computer science. So we have Balaji.
Hi everyone, myself Balaji. I'm from information technology. So today we are presenting NeoShark project.
Okay, now we start. We successfully set up. So my name is Samuel Damon. We are representing NeoShark. In one word, NeoShark, in one sentence, so NeoShark is an integrated, unified platform for students to learn. Built by students to students, right? Now we identify 2 problems. Problem 1, we're gonna demonstrate acting, ready? We're basically acting right now. Right. I'll give you the mic, so yeah.
Yo, Sam, please, do you have assignment 1, part 2?
Yes, I did finish assignment 1, part 2 for the communication a week ago. Why?
Yo, I have a problem, and I don't know if you can help me with that.
Of course. Let me look at my notes. I use AI to help my studies. So, when I'm in there, we have a lot of chat and stuff, but I have so many chats in AI that I can't find specific things I did. So basically, I lost all my notes for the class I did. It takes more time for me to discover it. So for that purpose, we created this NeuroShark, and now we can start to do the presentation, official presentation. So cool, play around. Hopefully. All right. Okay. Hopefully shows up really well. Sweet. Okay. We will especially use Canada for that. So this is our logo. This is our stuff, and we're gonna start with. Can we start? All right. Perfect. So introduction, right? We're introducing. That's the first problem. Second problem, we saw specifically jumping note, flashcards, and cruising across some multiple areas. So, okay, perfect. So here's the thing that we solved with this whole platform, right? First, student jogs notes and all this stuff, as well as flashcard. The second part of the problem we identified is the effective learning. We unified all in one place, and now we effective learning by using flashcard, quiz building, and all from your notes. Again, it's not, you're not getting from AI to generate for you the questions based on the sample you have. You're feeding the AI to get that information so it's more accurate. And basically, one close thing is that, like the problem we noticed that personalized learning in a unified manner. So solution basically come, as already mentioned, just let you know, a little quicker, so because we're running out of little time. But here's the demonstration, right? We can we go back a little bit? We can talk, but how about build it? And we build it successfully. And this is basically the working product. So this is a video. Want to say something? Good stuff, yeah.
Okay. Basically, this is NeuroShark. NeuroShark is a real app. We built it from scratch, and now it's 90%.
Using microphone.
Sorry. Yes, we built it from scratch, and for now it's 98% done. So you can see it. This is the front end. Can you? All right. So stop a little bit. Okay, cool. The authentication is very easy, very secure, very easy. It's like ChatGPT. When you go to ChatGPT, you just go, you put ChatGPT on the browser, right? On Google, and what you do, you just click on sign in. And after that, you use your Gmail, right? So it's gonna be exactly like that. So can you go back a little bit? Yes, sir.
Anyway, keep playing. Just let you know the video. Yeah, so I just want to let you know, like, because of timeline situation, it's a working product. As we go a little faster, so this introduction of the whole main page, login successful, so we care about authentication. Each individual has their own stuff. That's something that's a basically rated product. This is a dashboard. This main dashboard tells you like a description of what it is and how it works. Introduction for that. And next thing, coolest thing that we built here, right? So practice exam, right? So this is here. These are all your notes. All your notes are gonna be here. The coolest thing that you can make your own notes, like type in with words, but also we can do more. Can you keep playing the video now? We can press upload PDF, right? Choose the PDF what you want or whichever class. So we have the sample here, and boom, it's let it cook. Let it fly. Let's wait, and it's give you a detailed note down there. As you notice that it doesn't delete your notes, so it's built on top of it. So that's another big feature we have.
So basically, this is the text from the PDF, right? You extract the text from the PDF and then put it here. So you can see your note, and also you go to case study. Make sense?
So let me go a little forward. Don't move yet. So what happens now, once you press study, can you play the continue? It builds automatically a question based on the note. So it's a...
So thank you. So you can see that the first sentence is the whole sentence the way it is, and also skip this because this one is a fill in the blank question, right? So and then the answer is gonna be the word that you miss is gonna be the answer. Go ahead. Copy and paste.
So, but also we have, that's a performance rate, and also gives you how you're doing well, so we can keep track. But also we have next to the chat box to help you answer to the question. All right.
Okay. Questions for judges.
Anyway, okay, it's a lot of, this thing is compact and there's a lot of stuff in it. First we get pulled through it, but if you're interested, let us know. We'll get you all the details. Yes.
Great energy, and I love your presentation because you're the only team which actually can go and test product on real users. You guys have so many potential customers in this school.
Yes.
You should just go get out, give it to them, see how they use it, and go raise venture funds. Great job.
Thank you. I can add a little more on that. We build with a component base, means that if you have a client or students basically come to us and say, hey, I think this is effective way study, we can immediately implement it. We couldn't get there, but we already implement the canvas in there, so you don't have to look for download it. You just directly upload the PDF there, get the calendar, get the course information, all the stuff. It has high potential use case.
And also it's gonna be based on you. If you want to do fill in the blank, if you want to do flashcard, you choose whatever you want. You have the full power. Make sense?
How will it get the notes in the first place? Is it listening in class every time? Are you uploading stuff you've written? How does it get populated?
Two ways. As you saw in the demonstration, the upload button over there, which locally safe, so you can go Canvas, download, put it there. Next, we're working on it, I think it's halfway done, where it's Canvas dependent. Canvas has sometimes allow API to the course, so you press it, once it's there, it's uploads on your notes here. And again, I'll clarify, you see on the right side.
Notes are still being written manually by the student or what?
You have choice. Like it's already automatically, it generates you bullet point of very organized way. You read through it, the PDF, right? And then you can, if you want to have more notes on your own, you can put it in there and study those stuff as well.
And also, when you have to take the NCLEX exam for the student nurse background, so they give you a timer and all of that. So you can use this, and then you put your own timer, give you access to do that.
So it's good to study when you have the material, it condenses and summarizes that. But what about lectures from professors and class?
Yes,
lectures?
which is a great question. That's a new feature we're trying to implement where, is it here?
Yeah.
All right.
So also it's connected to your Canvas directly. So that means you just go to Canvas, you're gonna see there's a button with setting, you click on it and then you take the code, the token key, and you put it right here and all your codes will display.
Sorry, yes.
So I'm not a Canvas user, but
Gotcha.
I know that this is something that is used campus-wide.
Everybody,
so I think
yeah.
that's really cool that you have that integration. How, based on setting up that integration, how promising or easy or doable is it to set up integration with other platforms like Google Classroom, and what other platforms have you identified as worth exploring?
Because we focus on students, mostly it's the Canvas right now. If you haven't identified more platform that's like willing to open the API for us, we'll definitely take integration. The coolest thing is the modular design. It's component based. If we need something, we can add a build on top. And that's what makes it so interesting about this tool. It's a very modular design, focus on students. We discover every day new types of learning techniques style. So we just integrate those stuff, and eventually we'll have consolidated, unified platform area. And you're never gonna lose your notes because it's all organized in one place.
So currently you guys are specifically have designed this for UMass Boston, or is Canvas used in other UMasses as well?
Yeah, like if anybody, whoever using Canvas, like MIT Canvas, like they can use, everybody can. It's not only exclusive for UMB, it's exclusive for students like who will into the academic world. studying quizzes and.
Real quick, you see this? This is my classes. I have 5 classes. So I just use my talking key from Canvas, and it go right here. Once you press one of this button, it will auto-generate a folder, and it's gonna have nested file in it. So for me, I really don't need to go to Canvas. Everything is just classified.
So it pulls the files
Yes.
as well. You don't
And
have to manually
yes.
upload from.
Yep. You just have to click, and then it extract your PDF for you, take the text from your PDF, and take care of everything for you, and you're good.
But also you have the option to choose it, right? You want to go beyond just studying in the school environment. You decide some kind of outside of course, you can do that as well. That's why we created this tool to upload any PDF you want to download.
I see. Yeah, I think we had a company come through the BBC Sprout. You guys probably remember
Yeah,
that.
I think that's
Sprout was focused more on K through 12, or rather, I think maybe 7 through 12 or something like that. So I do think that it's quite interesting. I would definitely encourage you, if you haven't yet, do formalized testing. Actually get students to test it and get some numbers behind it. Not 5, not 10, like 100 to 500. Mobilize that, and that's going to give you a lot of really valuable data.
Thank you for the feedback. That's
so I would like to point out this is a team without a faculty mentor, so a group of energetic students, right?
3 of us, quite enough.
So I'm going to ask, okay, I'm going to ask the provost or the lead of education ask you some questions.
Yeah. Thanks. No, I'm very impressed by what you've done here, but I do have a question. So in terms of calibrating the output, right? Because different types of tests, different levels of expectation around, right? Whether the goal of a particular exercise that you're preparing for, whether it's a formal test or not, right? It should be different output if you're just having to essentially play knowledge back, or are you having to demonstrate critical thinking skills? Is there a way to set up the output so that depending on how you prompt it, you get different levels of responses in terms of practice questions or essentially guidance for studying, right? As we think about the taxonomy of learning objectives, right? You can go from very surface level to very deep questions.
Yes.
Can you calibrate this so that depending on what the objectives of the course or the exam are, that it can give different levels of feedback?
You want to take on that?
Yes. The reason is we have a very good analytic dashboard. The analytic dashboard is going to take track of your progress and also will suggest you what type of quiz you can take in order to be better. Make sense? Like for instance, for all of my classes, for the first day, I use one of the slides and then I try to answer the question with the flashcard. The flashcard will say, okay, I see that you're doing well in this, but I will suggest you, if you want to use fill in the blank. Make sense? So you will track everything, and based on what is gonna be better for you to progress, to be better, we create an analytic dashboard that will not only give you a roadmap, right? And also suggest you to use this type of pedagogic method.
And also, to directly answer to your question, is that because we build this modular design, you see this on the right side of the chat, we can make a rack chat based. What it means is that we just basically take because it's divided, it's very comprehensively organized based on project, based on notes, we can take that and fit in there and make it with a specific call if you want to work on that. And that's where you can specify, like, this is the thing I'm having issue or problem. But it's based on the way we build this application is doable, and definitely we're looking for more perspective. I think that's what she's pointing out, where give it more survey, get the people out and see what kind of exactly looking for, and we're happily able to integrate because we build is that in mind.
Yeah, and let me say, I'm so excited, when you started talking about, right, students building a tool for students, that is great. Awesome. But then I think you can be even more helpful to students, and you do need to focus on students first. I absolutely agree. But I think that there's some other expertise that could really help you, in terms of folks who have pedagogical, curricular, assessment expertise. Once you have enough student data, they could, I think, be really helpful in getting you to be able to sort of build the output and the dashboards in ways that will also respond to how instructors would be thinking about the construction of different forms of assessment.
No, I think that's great, actually. Thank you for that. That's a really way to think about it. Thank you.
Our final team is Team Brady Bunch, and their project is Autofolio, and it generates a portfolio website.
Team Brady Bunch.
For the team to set up everything. So what we're going to do is after the last team presentation, all the judges will come here. We're going to have an internal meeting, decide the top 3 awards. And also don't forget to cast your vote as people's choice. You do have your own power to decide the people's choice award, okay? And then we're going to have the award ceremony and the fair chat, conversation with the provost and Paul English and the student advisory council in a different classroom, the TEAL classroom. And then we had a box lunch order for all of you, so it should be somewhere, in the university hall, okay? So don't miss the award ceremony in the afternoon. We're gonna start around 1:15, okay?
Good afternoon, everyone. We are here presenting our project Autofolio, Automate Your Portfolio, and this is done under the guidance of our professor Yuxing Wang. So, coming to...
Are you talking about financial portfolio? What portfolio are we talking about?
It's like a student portfolio. Yeah. I mean, that's
for students.
Yeah. Okay. So a little story behind the name and the project itself. Firstly, our name, Brainy Brunch. That's because we were having a couple of conversations like we always do, our team. And during one of the brunch times, we had this discussion where I was struggling and I was talking to my friends saying, I come from a non-technical background. I'm a business analytics student graduating this December. I need a portfolio, but not with a lot of technical stuff to go with. And that's when we came up with this idea, Autofolio, where you can automate your portfolio, the student portfolio. So what are the challenges that we have observed for coming up with this project? And the key challenges are limited time during job search. Do I have to sit down and apply, or do I sit down and learn the tools to build my portfolio? That was a major part that was being focused on. So students don't usually consider portfolios unless it is required because of the time constraint, and time management and workload management is something we all struggle with. And the second challenge being non-technical students like myself, where I am being focused on building my skills and my projects around data visualization, Tableau, and other stuff. And coming to just create a portfolio, I wouldn't probably want to waste my time learning HTML, JavaScript, CSS, and also code hosting, which would be done in GitHub. So this is another challenge that we've noticed. And third is the perception that portfolios aren't worth the effort. While working on this project, we did a lot of research, and we've read a lot of research papers, and we've also seen some online forums where we've noticed that students feel that due to lack of self-motivation, they usually don't go for building a portfolio project of their own. So how are we solving this challenge? We solve this challenge with Autofolio, where we can generate a complete portfolio website instantly with an appealing design. So it's literally like you just click, add some details, and boom, you have a portfolio website of your own. So how Autofolio works is that students like all of us, and me, who is from a non-technical background again, I will click on portfolio, create your portfolio, and then I would be asked to enter my skills, my projects, about me, experience, and then from the back end, the AI does the part where it is transforming all of this information to create a ready-to-use portfolio website. The main purpose of Autofolio is that it is quick, no code, and with these two, it's creating a professional website for students like me and many others. And what makes us different? One is the universal layout that we are offering. So I myself have gone into a lot of websites where I wanted to build my portfolio, but I have seen that though they are simplifying it, it still looks complicated because they have a lot of options, customization. But this, we are giving a universal layout, so that makes it easier for me. And we are also offering not just one, but a couple of template options that students can choose from. And the best part is it is built for students by the students. Only a student can understand the struggle and the pain of another student, and that's the main idea behind. And definitely the subscription needed. Money. Being a student, it's not easy to pay for a lot of subscriptions and then get the work done. So there is no subscription needed, and that's also another factor where it's making us different.
So coming to the use of AI, like what we used exactly under the hood, we used Google AI Studio, where we got our APIs from. We used Gemini 2.5 Pro for the image generation, which would help us in generating the whole images on the website. The text on the website, and then Nano Banana, which is also a Gemini API. We use this for putting our pictures on the website as well. And then we planned on integrating our videos as well, which will help to make your portfolios even more beautiful, right? But it is not yet done, so that is something we are planning to integrate in the future. And we also have multiple template colors that once a person integrates and chooses what color they want, it can generate based on what color they prefer. So yeah, what's the process? Process is you filling out the form, right? It's like we have two types of forms that you can fill out. One is when you give your details, like what's your name, what's your professional tagline, what's your email, all the basic information. Another way around is when you are able to just type a whole prompt saying from starting to end, this is about me, these are the details about me. So one single prompt or a place where you can structure yourself, both of this, it will be able to generate the website. We have a demo actually, but this is how it looks. This was the old version of it.
You have 1 minute left.
Yes. Yes, one second.
Right, so our target market for this application, of course, for the students, but you can see that the student who desire to add their website into their resume instantly, this is the point that I want to point out. As like my friend, she doesn't have the technical skill for like front end and back end, and this is really important. And also, for our vision ahead is that, so I think that we need to create a survey that from Maria suggested for the previous presentations. This is important. This is because it's gonna make our application and idea more stronger, and I really strongly believe that this makes our students stand out. And this is all about our presentation. Thank you very much.
5 minutes, then you can have lunch.
Can we see what a portfolio looks like?
Yes, sure. Because we couldn't show it. I forgot to.
You can circulate it, we can look at it one table at a time. So that was my question as well.
I'm so sorry. So this is how it looks like. So once I give the details to it, it will be able to generate.
Yeah, go ahead.
These are the details that is already provided and it's generated already, because it takes time for the API to fetch the details and put it on the website again. So the more the detailed the prompt is, the more better the website is going to be. So I just gave about me as a small stuff, and then it just generated the whole text by itself based on the document that I gave.
Okay, got it.
And the skills and technologies or everything.
Okay, great. Okay.
Can you show the rest?
Yes.
Oh, it's
generated already.
Yeah.
So that's how it came. And once you fill out the details, it's going to reflect on the website on the site. This is all generated by the APIs. And then we also provided a way to download all the zip files. So for example, once the student can only visually see it, right? But when you want to host it by themselves, you'll be able to download the zip file. So once you download the zip file and you host it on your GitHub pages, you will be having your own portfolio.
Just provide hosting and then you can steal LinkedIn. Finally someone will steal LinkedIn. This is slow, right? Like
the generation process?
yeah, because like people need portfolios. By people I mean like people outside of engineering, because engineering uses GitHub, and then like business and design students, and then they use LinkedIn. But in LinkedIn you can't actually like show your beauty and like your creativity. So you should just host it, and then people will go to your website instead of LinkedIn.
But then for us to host it right now, like the drawback we had is it's API calls, right?
Yeah.
And we're using free API tie-up for now because it was approx $300 for us to use it.
Yeah.
So that part of it was the only thing. So if we have to host it, then we need an API call that will be useful.
You'll need to charge people. Just charge people because the portfolio should not be free, right? Like charge people.
I'm pretty sure that there are a lot of services that exist like this, so I'm wondering if there's an angle specifically for students. One thing that you said is that it's a free tool, right? So I know that higher ed is very focused on the path of students after they graduate. So you could potentially have a commercialization path where your customers are schools, right? It's gonna cost something. You could bring the cost down and also customize the form, the templates specifically to what do different majors need to present. An art portfolio, for example, could be, a writing portfolio, an art portfolio, a tech portfolio. But I'm wondering if there's a pathway with the higher ed specifically, because they would buy a tool that helps them differentiate the career services path. I would still keep it really affordable and really easy to use, but I would examine what Wix has. Wix has a tool to optimize a website and also kind of plug and play. So just I would try to find something proprietary, but if you can't, maybe the way that you commercialize and promote it could be the way that you differentiate.
Also, it's not just singular field. It can be any field. For example, when we tested it out, I tested it out for a technical perspective, and I gave it to my friend and asked her to test it out for her perspective on how analyst would have her portfolio.
Yeah.
And then it was able to generate based on her skills and the context she gave as well. So it's basically the prompt instead, right? How you prompt it, that's how it's supposed to be generated.
And that's great that it's flexible.
It's flexible.
I'm talking more like how do you move to implementation?
Okay.
And I would also say that another thing that comes to mind is high school. The last couple of years of high school, everyone is on that path of where am I going to apply? I need a portfolio. Parents are too busy. They don't have time to do this. So it could be, especially with the really ambitious, more upscale communities where there's a lot of competition for specific schools, you could have a commercialization platform.
Wonderful. Okay, so that concludes this morning's computation. So let's take advantage. We have the photographer in here. Let's take a group photo. Okay, so maybe everybody. So Ning, what is the best way for us to take group photo? So facing. Okay. So students, computation team, everybody, could you go to this place? Okay. So let's take a good photo together, and the judges will meet and decide the top 3. Okay. So let's do this. Hurry up, stand up. Let's take good photo together. Okay.
Yes, nice job.
Yes. I want all of you to go there, Xiaohui. Okay. Let's take good photo together. Everybody.
Maybe in front of the computer.
Uh-huh.
Maybe in front of this.
In front of the computer, right?
Yeah.
Okay.